Examples. Solve using substitution. So let's try the first set of equations. Negative 3x plus y equals negative 14 and 2x minus 7y equals 22. Step 1, we gotta have one of them equal to a variable. In other words, solve for one of the variables. Let's solve for in this one. Negative 3x plus y equals negative 14. That's probably the easiest one because it's got no number on the y. So be aware of that. If there's no number on the y, it'll probably be one of your top choices. So let's get rid of the 3x. So let's add 3x to both sides, plus 3x. There we go. So 3x on the left side cancels out, and that gives us y equals positive 3x minus 14. Be aware. We want to make it equal or make it easier to visualize by putting in slope-intercept format. It sometimes helps, most often. So in this case, let's notice the next equation, 2x minus 7y equals 22. We're going to use substitution on that one. We're basically going to substitute the y value that we previously found to be 3x minus 14. So let's replace it. There we go. So 2x minus 7 times in parentheses 3x minus 14 equals 22. So now that we replace or substituted, I should say, the equation for y, now let's distribute the 7. So we're going to distribute the 7 to the 3x and the 7 to the negative 14. So that way we have 2x minus 7 times 3 gives us 21, negative 21x. And negative 7 times negative 14, negative, so positive. 7 times 14, 98. This is probably where your calculator could come in handy. I'd highly recommend that, and double check my answers as well. So 7 times 14 should give you 98. On the other side, still equal to 22. So now let's go to the next step. Let's combine the x's. 2x minus 21x will give us negative 19x. So negative 19x plus 98 equals 22. Now it's a single x. So let's solve for x then. So let's get rid of the 98, minus 98 from both sides. 98 cancel on the left side. Therefore we have, in this case, negative 19x equals negative 76. So 22 minus 98 should give us 76. Quick check with your calculator may not hurt, right? So once again, turn on your calculator, clear anything that you might have, or go back to your main screen in this case. So 22 minus 98. Yep, just a quick check. Yeah, you see it gives us negative 76. Okay, let's go for the next step then. Next step, solving for x, get rid of the 19. So divided by negative 19, divided by negative 19. Once again, this is where your calculator could be handy. Negative 19 divided by negative 19 cancels out. Negative 76 divided by negative 19, negative will give us a positive. And this is where we can divide negative 76 divided by negative 19. Do remember to make it a negative sign, not the subtraction sign, negative at the very bottom next to the enter button. And that should give us 4. So our answer for x, in this case, x equals 4. Okay, so next step, solve for the remaining variable. And let's use this intermediate step. We can use one of the original formulas, but why use the original when this intermediate step already has y solved for? So y equals 3 times, and replacing the x value with the 4 that we just found. 3 times 4 gives us 12. 12 minus 14 now gives us negative 2. So there's our second value that we were looking for. The y value is negative 2. So our coordinate and final answer, or coordinate point, is 4 comma negative 2. So in this case, we found that it's a single solution, so it's a consistent system with one solution. And let's do a quick check, just to make sure it works. Let's use one of the original equations, very top right equation, so substituting for x and y. 2 times 4, 2 times 4 will give us 8. Negative 7 times negative 2, negative is positive. 7 times 2 would be 14. So 8 plus 14, does that give us 22? Yeah, it does. 8 plus 14 gives us 22. So we just checked that it's a correct answer, the one we previously got. Okay, so let's go for the next one. Next one, or next set of equations, I should say, y equals 4 minus 2x and y equals negative 2x minus 5. Step number 1, do realize step number 1 we've already completed. Well, we didn't have to do much in this case. Since they're already in the form of y equals, one of the variables is already solved for. We don't want to do any more work in that, right? In this case, we don't want to solve for x because it's already y equals. For some reason, this tends to be the more complex example for many people. Not sure why. In this case, be aware, if both of them are y, if y equals 4 minus 2x and y equals negative 2x minus 5, why don't we just say both of them are equal? So in other words, 4 minus 2x is equal to negative 2x minus 5, because they're both y technically. So be aware of that. Don't make it too complex. Just say they're both equal then. And now let's solve for x, meaning let's get rid of the x to one side or the other, your choice. In this case, it wouldn't make a difference because we're adding x, 2x to both sides. Do notice, as we add 2x to both sides, well, they kind of cancel each other from both sides. Ooh, what happens then? Well, all we're left with is the 4 equals negative 5. Is this a true statement or a false statement? This is a tricky one, What's a false statement, right? 4 does not equal 5. So this is what we call then an inconsistent system. In other words, two lines that will never cross each other. Parallel lines, right? So let's go for the next set of equations. Y equals x plus 3 and 2y minus 2x equals 6. Okay, notice, step 1 already completed. We have y equals x plus 3. Already have y solved for. So we're going to substitute then. Substituting into the other equation, into the 2y minus 2x equals 6, and replacing the y value with x plus 3. So 2 times x plus 3 in parentheses, and then minus 2x equals 6. Notice, in this case, we do need the parentheses, agreed? So, distributing the 2 to the x and the 3, that will give us 2x. 2 times x is 2x, 2 times 3 is 6, and we still have left bringing down the negative 2x. And let's not forget the 6 on the other side of the equal sign. Let's combine the x's. 2x minus 2x, hey, they cancel each other out again, right? That leaves us with 6 equals 6. Is this a true statement or a false statement? Well, the 6 equals 6? Yeah, that's a true statement. So in this case, we define this as dependent system. Well, if we try to take, for instance, the equation 2y minus 2x equals 6, let's solve for y. Let's solve for the y values. Let's get rid of the 2x, so plus 2x on both sides. That leaves us with 2y equals 2x plus 6. And I'll just get rid of the 2 by division. Divide them by 2. And remember, do it individually. It'll make it easier for you in the long run. 2 divided by 2 cancels out. And 2 divided by 2 cancels out, or gives you 1, right, for the x. So we have y equals x, and then 6 divided by 2 gives us 3. Y equals x plus 3. Hey, look at that. That equation that we just simplified is exactly the same as the equation up at the top on the left side of it, right? They're both y equals x plus 3. In other words, one was a multiple of the other. So that's it. We're done with this. We have in 3 different case scenarios. One is the consistent system. The second one was a parallel or inconsistent system. And the last one was a dependent system. Be aware. I've already kind of explained this in a previous video, but for reference, let's take a look at it again. Here's sort of the idea. When 2 cars intersect each other, it is sort of the definition of a consistent system. You're looking at a single intersection point. 2 cars crashing into each other. Ideally, they'll never crash into each other. And then we have an inconsistent system, 2 parallel lines or 2 cars that are traveling side by side, never crossing each other. And then the dependent system is a line on top of a line, or as an example, a car following another car. The question is, at what time were they at that particular place that you're wondering about? Agreed? So that's sort of the case scenario here. Hope that serves as a reference for this case.